let's discuss dative or coordinate covalent bonding or coordinate covalent bonds. Now, we've discussed polar, non-polar. If you've not watched our lesson on polar and non-polar, please you can check it out on our channel as well. So, dative or coordinate covalent bonding. Don't forget, once covalent comes in, it means there is electron sharing taking place. Is that okay? But for dative or the coordinate covalency, only one of the bonding species will donate the electron pair to be shared. Only one of the bonding species will donate the electron to be shared. So for the dative covalency, our keywords here is that only one of the bonding species donates the shared pair of electrons. Only one of the bonding species donates the shared pair of electrons. Is that okay? Another condition needed for dative covalency to occur is that apart from only one doing the donation, the other one should also possess an empty orbital. Empty atomic orbital from the other species involved in the bond. So, one is going to do the electron donation. It means that that one that is going to do the donation should have lone pair electrons that he will be capable to donate. And then the other species involved in the bond should possess empty orbitals to accommodate the donated electron pair. Let's look at some examples of species that exhibit dative covalency or the coordinate covalency. So common examples of species that exhibit dative or coordinate covalency, we have the ammonium ion and the hydrazonium ion. The ammonium ion and the hydrazonium ion. So we're going to use this as our basis for illustration. So we have H3O plus and also we have NH4 plus. Is that okay? Now let's explain dative covalent bonding in H3O plus and then in NH4 plus. In H2O plus, it is formed between H2O and then H plus. So we have H2O. So this is H2O. We are looking at the formation in H2O. So we said there's going to be electron pair shared between this. There's going to be electron pair shared here. Is that okay? So we can see that there is one lone pair here, another lone pair here. Now, the second species is the H plus. This is the H plus. Is that okay? What is the meaning of H plus? So hydrogen has one electron. So if hydrogen loses this one electron, it becomes H plus. The H plus here indicates that the hydrogen has 0 electron in its orbital. So for dative covalency, one should possess lone pair electrons that will be donated. So for dative covalency, one of the bonding species should possess lone pair electrons. And then the other species should have an empty orbital. Is that okay? To satisfy the formation of dative or coordinate covalency. So the H plus here has an empty orbital. And also in H2O, there is 2 lone pair electrons on the oxygen atom. Now, this hydrogen ion here will then come and form a bond with any of this lone pair without donating any electron. Is that okay? So the electron that will be donated for the two species to enjoy the covalency is coming from the H2O, specifically the lone pair electron on the oxygen atom. So the H plus will then come and enjoy this lone pair electron here, so that it will have two electrons attached to it, which makes it stable. And already the oxygen is stable as well. So the type of covalent bond that occurs here between this H plus without donating any electron, and then the oxygen atom in water donating this lone pair electron to be shared between the H plus and then the oxygen atom in the H2O is what we call the dative or the coordinate covalent bond. It is a covalent bond because there is electron pair shared between this O and then this H. It is a dative bond because the hydrogen ion didn't donate any electron, but only the oxygen atom in water donated the electron pair, and that is being shared between the two atoms. Is that okay? So this formation will lead us to the compound, the H3O plus. And this is a dative covalent compound. Let's look at this one as well. In this one, we have ammonia and H plus. So we have NH3 and H plus. So first of all, let's look at the formation of NH3. So in NH3 we have nitrogen with 3 hydrogen atoms. We said nitrogen has 5 valence electrons and hydrogen 1 each. So the covalent bonding we indicated here, electron pair shared, so 2, 4, 6, and then 8. So in nitrogen, there's 1 lone pair electron on nitrogen. Is that okay? So H plus again. So H plus will then come and enjoy the lone pair electron on the nitrogen in ammonia to form what we call again the dative or the coordinate covalent bond. So there is a bond that exists between the nitrogen atom in ammonia and the H plus ion is called the dative covalent bond. Again, it is a covalent bond because there's electron pair shared between the two species here. It is a dative bond because the electron pair that is being shared is donated by only the nitrogen in ammonia. And then this is coming without any donation, but they are all sharing. And this is stable, and this is also still stable as well. That is dative covalency or the coordinate covalent bonding. If you've not subscribed to our channel, please, you can try and subscribe to our channel to enjoy more lessons.